back and forth.
No, I said.
Okay, so here we go, guys.
Pretty cool.
Yesterday, we started 2.2, okay? And we talked about slope, right? Talked about all the different things slope was, and we found the slope between 2 points. Do you remember?
Yeah.
Very good. Okay, so today, we're going to talk more about slope. We're going to finish 2.2. All we'll lack is 2.3, and we're going to cover that Monday. If I don't finish it Monday, I can finish it on Tuesday. Then we'll review on Tuesday, and we'll test Wednesday, Thursday, which means that the worksheet that you just got is due on Wednesday.
Woo.
Okay? So, let's talk about the different kinds of slope. Look at this line right here. Tell me what kind of slope it has.
Positive.
Very good. So when you're looking at the slope of a line, you're reading the line from left to right. Do you understand that?
Yeah.
Just the exact same way you would read a book. That's the way you read the line. When you read this line from left to right, what's the line doing? Is it going up or down? Up. So you might say that this function is increasing. Have you seen that word before? On your optional project? Are you with me?
Yep.
Increasing from what? What's all the way to the left?
The order.
Negative infinity to all the way to the right. Positive infinity. This function is ever increasing. That's all he does. From negative infinity to positive infinity, this function's increasing. Okay? A positive slope. Now, what about this guy right here? What kind of slope does he have?
No correlation. No.
What kind of, well, okay, let's do this. What kind of line is it? What's it called? Okay, so he's a vertical line. Okay, what kind of slope does a vertical line have?
None. Or
None? Listen to me. People, if I stood on this line with a pair of skis, would I go somewhere?
no.
Oh, yes. Well, how can you say it has no slope? People, this thing right here has so much slope, I can't even tell you how much slope it is. Okay?
Wasn't 180 degrees? Like just downward?
Undefined.
His slope is undefined. Undefined. It's so steep, I can't even define it. So when we find slope, remember the slope formula is delta y over delta x? So when you find the slope, it's going to be in a fraction. Do you agree with that?
Yeah.
Okay, what's it going to look like so that it's undefined?
It'll be y equals x.
Nope.
No.
It's just going to be a number, guys, but what's the fraction going to look like? What makes something undefined?
Something over 1.
Something over 0. That's exactly right. So when you find a slope and you get some number, I don't care what the number is, if it's over 0, then that is undefined. If you leave it like this, I will mark it wrong. If you leave it as a number over 0 and you don't tell me that it's undefined, I will mark it wrong. I will not give you partial credit. I will give you no credit. Does everybody understand? Okay. Will my calculator tell me it's undefined?
No.
What will he say?
0. Or error.
He will say error. And he will say error division by 0. Okay? He won't tell you it's undefined, but he's saying, hey man, you can't divide by 0. That is not defined. Okay? What if I was going to write the equation of this line? Does anybody know what it'll be?
Y equals x over 0.
No, if it's a vertical or a horizontal line, it only has one variable in it. Does anybody know what the variable is here? He's an x. X is equal to some number. X is equal to 2. Then you'll go to 2 on the x-axis and draw a vertical line. Okay, x is equal to -7. You'll go to -7 on the x-axis and you'll draw a vertical line. So x is equal to a number. All right, let's talk about this slope. What's his slope?
No slope.
What's the number for no? None. 0. All right, so this guy, he has 0 slope. If you stood on this one with a pair of skis, what are you going to do?
Stay still.
Yeah, you're just going to stand there. You're not going anywhere. Okay? So what is this going to look like as a fraction?
0 over a number.
There you go. He's going to be 0 over a number because, guys, 0 divided by any number is equal to what?
0.
So if you don't write 0, if you leave it like this, I'm gonna mark it wrong, because it says you don't even know what 0 over any number is. Okay? So here's what I'm telling you. This is what I'm looking for, and this is what I'm looking for. If you leave it like these, I will mark them wrong. Okay? Does anybody know what, this is a horizontal line. Do you agree?
Yeah.
Do you know how to write the equation of a horizontal line?
Y equals a number.
There you go. Y equals a number. Okay, now do you think kids mix these up all the time?
Yeah.
Okay, so watch. I'm going to show you a silly way to remember. Okay, look up at the board. You see this Y? Are you watching him? You see him? Everybody looking at him?
Yeah. The tails.
What is he now?
H.
He's an H. What's he stand for? Horizontal. He stands for a horizontal line. Y'all, a Y. He's like screaming at you. I'm a horizontal line. Look at this X over here. People, that is 4 V's all stuck together. What's he screaming at you? I'm a vertical line. Okay? So that's an easy way to remember it. All right? We'll talk about it again because it's going to come back up. All right. The only other one that we haven't talked about, what kind of slope is this? Negative. What is this function doing from negative infinity to positive infinity?
Decreasing.
Decreasing. Very good. That's the word that's used on that optional project. Okay? So the only thing that I have to say about a negative is I want to tell you that negative A over B. You're just going to have a fraction. Okay? It's negative. That means your line's going down. Is that the same thing as negative A over positive B?
No.
Yes, it is. A negative over a positive, unlike signs when you divide, is what? Negative. Is it the same thing as A over negative B? Yes, it is. It's all the same. Okay, so it doesn't matter how you write it. It all means the same thing. Okay, so let's work 2 problems like with this example. Example 3. I want you to tell me, does my line rise, fall, is it horizontal, or is it vertical? Okay? I want to tell you, you have to pick one of them. So let's talk about the slopes. If the line rises, what kind of slope does it have?
Positive.
If the line falls, what kind of slope does it have?
Negative.
If the line is horizontal, what kind of slope does it have?
0.
What is that going to look like as a fraction?
Something.
0 over a number. Okay? That's what it's going to look like. If it's vertical, what's its slope going to be?
Undefined.
Undefined. What is that going to look like as a fraction?
Something over 0.
Yeah, some number over 0. Okay? Be careful with those 2 things right there. Y'all, 0 divided by anything is 0. But if you can't divide, remember when you learned about division in the 6th grade and your teacher said you cannot divide by 0, it's undefined. It's not defined. Okay? All right, so here's our first problem. Are you ready?
Sure.
I'm going to give you 2 points, and you're going to tell me what the slope between them is, and then you're going to tell me what does my line do. Okay? So my 2 points are -5, 1, and I'm going to help you get started on this one. 3, 1. Okay? So what was the little trick that I taught you yesterday, okay, about to help keep you from making mistakes? What did I tell you to do with your points? Stack them. Okay, so you can put this guy above it or below it. It doesn't matter. And then what else did I tell you to do?
Look at the X's.
No. What else did I tell you to do?
Match them, like map them.
Circle the Y's? Why did I tell you to circle the Y's?
Because.
Were y'all in class yesterday? Did we not do this?
No.
We didn't do this because okay. I'm okay now because I'm like thinking, what is wrong with y'all? Okay, so here's the deal. We never did do a slope problem yesterday, did we? We got the formula and then the bell rang. Okay, so here's what happens. When kids have 2 points that are like this, when you start looking back and forth between these 2 things, then that makes you mix the numbers up sometimes. Okay, you look at the wrong one and you put it in the wrong place. So my sister, who's dyslexic, okay, she stacks her points like this. The most common mistake made with slope is to put the x's on top. Why?
Because change.
Yeah, because look, who comes first in this point? X. What's the first thing you see when you look at it? The X. Okay, so kids start working with the X. So I say circle the Y's because the Y's go on top. That's what we want to do first. Okay, so when I find my slope, delta Y over delta X. The change in Y over the change in X. So does it matter which one of these Y's comes first?
No.
No, but whichever one you put first, then you have to put his X first on the bottom. Do you understand what I mean? You can pick whatever order that you want, but once you pick the order, you have to keep the order. Okay? So I'm going to pick this guy down here first. 1 minus 1. Since I picked this guy down here first, who do I have to pick first on the bottom? 3. Now watch up here on the paper what I do. You can't throw anything away. 3 minus a negative 5. Do you see how minus a negative makes a plus? Okay, what's 1 minus 1?
0.
What's 3 plus 5?
8.
Now what I want you to see is even if you did it the other way, even if you said 1 minus 1, and on the bottom you said negative 5 minus 3, what's negative 5 minus 3?
-8.
Is 0 over 8 the same thing as 0 over negative 8?
Yes.
So it doesn't matter what order. What is 0 over 8? 0. What is my line doing? Rising, falling? Is it horizontal or vertical?
Horizontal.
Very good. Okay, so I want you to use this trick. Every time I give you 2 points and tell you to find the slope, I want you to stack the points and circle the Y's. You're stacking the points so that you get them matched up together. X's go with X's, Y's go with Y's. Okay? And I want you to circle the Y's so it's the first thing that you look at. Here's yours. You're going to try it. Are you ready?
Sure.
So your point, 4, 6, and 4, negative 1. I want to know, does it rise? Does it fall? Is it horizontal or vertical? Be careful when you circle them not to knock a sign out, okay? So that's easy to do, especially if you're being sloppy. So you might have said negative 1 minus 6, or you might have said 6 minus a negative 1, which would be a plus 1. You're either going to get negative 7 or you're going to get a positive 7. But on the bottom, you will get a 0. What is 7 over 0?
0.
Undefined. Undefined. Okay? So what kind of line do I have? Vertical. Anybody got a question?
Nope.
People, you're going to have problems like this on your worksheet. Okay? Problems like that on your worksheet. Problems like that on the test. Should we be okay with these kind of problems? We should. We shouldn't make careless mistakes with those problems. Okay? All right, so here's the next thing I want to talk about. The next thing I want to talk about are parallel. We're going to talk about parallel and perpendicular lines. What's the symbol for parallel?
2 lines like that.
Yeah, looks like 2 little L's, just like this. Tell me a real-life example of parallel lines.
Beams.
Beams, okay, beams in a ceiling, they do run parallel. Okay, what else?
Walls.
Walls. The wall on the left and the wall on the right are parallel to each other. You get it? Train tracks, double yellow lines on the highway. All right, all of those are parallel lines. Tell me what you know about the slopes of parallel lines.
They're the same.
Very good. The slopes are equal. So could I say m sub 1 is equal to m sub 2?
Yes.
The slope of the first line is equal to the slope of the second line if my lines are parallel. Okay, so just the subscripts only mean that those are talking about two different slopes. Everybody okay?
Yeah.
All right, so let's talk about perpendicular.
Like a sideways T.
Okay, so it's a what?
Sideways T.
Not sideways, but upside down. Okay, so that's the symbol for perpendicular. All right, tell me, what does perpendicular mean?
They
I
touch.
was saying intersecting.
They intersect to form a what? Yeah, meet to form a right angle, which is 90-degree angle. Okay, what's the symbol for a 90-degree angle?
Like a little, like, square.
Yeah, a little square right there in the corner. Okay, a little square right there in the corner. All right, so, or do all perpendicular lines look like this?
No.
No, couldn't I have one that was right here? And then the other one would come in here just like this. Do you agree with that?
Yeah.
Those are perpendicular. They meet to form a right angle. What if I, pardon me, what if I told you that the slope of this line was 3/4?
The other one.
He's
would
a
be
positive because he's going up. First of all, what do you notice about this line?
It's
It's
decreased.
perpendicular.
Yeah, so he's negative, and then what do I do with this number?
Drop it down.
Nope,
It's flip
you
it.
flip it, yeah. 4/3. So they are opposite, that means they have opposite signs, reciprocals. Okay, so write that down. Slopes are opposite. That means they have different signs, one's positive and one's negative. Reciprocals. What's another word for reciprocal?
Flip.
What was that funny word?
It's that funny word, it is. Multiplicative inverse, that's exactly right. Way to go, Garrison. Multiplicative inverse, that is a reciprocal. Okay, so we're gonna play a game. Are you ready?
Sure.
All right. So I'm going to tell you what the slope is, okay? And then you're going to tell me what the parallel slope would be and what the perpendicular slope would be, okay? Now listen to me, math's like a game, okay? Everything we do in here is like a game. The object of the game is to make the most points, right?
Yeah.
All right, so don't yell the answer out. I'm going to tell you that the slope is 4. I want you to write down the parallel slope and the perpendicular slope. Okay? Write down the parallel slope and the perpendicular slope. You got it? All right. What's the parallel slope?
4.
4. People, if y'all missed that, shame on you. Okay? What about the perpendicular slope?
-1/4.
Very good. -1/4. All right? So I'm going to do another one. Are you ready? Justin, you with me? All right. Come on. We got about 20 more minutes and then we'll be through. -2/3. -2/3. George, with me? What's parallel slope? And what's the perpendicular slope? What's parallel?
-2/3.
What's perpendicular?
3/2.
Very good. All right, here comes the last one. It's going to be a difficult one.
You said that was difficult.
For some kids it will be. Some kids will be like, whoa, I'm not really sure what to do with that. All right, what's parallel?
0.
What's perpendicular?
0.
Undefined.
He's undefined.
But wouldn't
But
the
this
slope
is
also
0/1. Is that true?
Yeah.
0/1. When you flip it, what do you get?
be -1/0?
1/0. What is
thought it was so
anything
easy.
over
What
0?
happened?
0.
Undefined. Undefined.
What happened to it being so easy?
Okay? Undefined. All right, so let's try 2 problems. Are you ready? All right, so here's the first one. The first one, I'm going to tell you, here, oh, I forgot to write the directions. This is example 4. Okay, we're going to classify our lines as parallel, perpendicular, or neither.
Says on.
Okay? classify as parallel, perpendicular, or neither. So line 1 contains the points -2, 2, and 0, -1. Line 2 contains the points -4, -1, and 2, 3. Okay, what do you have to find? Slope. You got less than 2 minutes. Go. You got less than 2 minutes. George, it's hard to write like that. Let's go. Is that what y'all got for your first slope?
Yeah.
Okay. All right. I just got finished marking a whole bunch of problems wrong on a pre-cal worksheet because they left answers like this. People, what is a negative over a negative?
Positive.
What divides into 4 and 6 evenly?
2, 3.
So, what are these?
Perpendicular.
What are they?
Perpendicular.
They're perpendicular. They're opposites, and this is 3/2 and this is 2/3. Opposite reciprocals. My lines are perpendicular. Anybody got a question? Is this hard?
No.
Okay, so let's do another one. Line A and line B. Okay? Line A and line B. Line A contains the points 1, 2, and 4, -3. Line B contains the points -4, 3, and -1, -2. Tell me, are they parallel, perpendicular, or neither? What time's the band leave?
I don't know.
What?
I'm not too sure.
I would say what, 10
40? Okay. All right, I got one more problem after this. Is that what y'all got for the first one? Okay. Notice how I always start out with writing my slope? Do you think that's because I'm trying to memorize it?
No.
No, I already know it. But here's what happens. When I start out with something that I know, my brain goes, wow, you're smart. Okay? And the smarter I think I am, guess what? The smarter I am. Okay? Y's on top. 3 minus a -2. -4 minus a -1. Are those the same thing?
No.
Yes, they are. Parallel. Anybody got a question? Okay, so the next thing we're going to talk about is the last problem. It's a reading problem. Okay, we're going to talk about the giant sequoias. Do y'all know what it is? It is a tree. Has anybody ever been to the redwood forest in California? Okay, so is this not true? This is what the giant sequoia is. Is that not true?
I don't know. I've never been there.
Y'all, listen to me. These trees are huge. When they say giant sequoia,
They're like 1,500 feet tall.
yeah, they're like when
massive.
it's a phenomenal thing. If you've never been there and you ever get a chance, it is. This is what you feel like when you stand beside one.
The tree
You're
trunks
like,
are large
wow.
enough to drive on through.
Yes, there is one that you can drive through the tree. Like they cut the tree out and the road goes through the tree. You drive under and through. There's a tree on each side of your car.
So
Okay? And it's not even like they're unreal. The pine cones are giant. The pine cones are huge. They're this big. It's enormous. Okay? Let me tell you a cool fact about the great sequoias.
Supposedly, it like breaks because of
Here's what the great sequoias. Let's say that last night we had a really bad storm and it broke off a limb right here and the limb fell down to the ground. Okay? This tree being really tall, does that make him lopsided and likely to fall over?
Yeah.
Yes, it does. Y'all listen, my husband's 6'5". Does he roller skate?
No.
Oh no, he doesn't roller skate. Okay? He doesn't roller skate. That's way too far to fall. He'll hurt himself, right? So this tree, if it drops a limb on this side, guess what it does? It'll drop a limb on this side to even itself out. That's pretty cool, isn't it? You're like going, what? A tree? Yes, he'll cut off the supply to a big limb over here, and he'll drop this limb in a couple of months. All right, so it falls off, so he can stay upright, and he doesn't topple over.
So,
Okay.
so if you build a tree house, just like on one side that's supported by two trees,
I don't know. I don't
will
know
it like
about
drop
that.
its own leaf?
I don't know, because it wasn't something that happened to it. All right, so here's the deal. Here's what it says. It's a reading problem. Use the diagram. So here's your diagram. In 1965, we measured a tree.
Excuse me, teachers. At this time, will you please release all band students for the pep rally? All band students for the pep rally.
Okay, y'all go ahead. We measured a tree and it was 137 inches across. In 2005, we measured the same tree and it is now 141 inches across. Now, for some of y'all, you go, so what? Let me show you how big 137 inches is. 137 divided by 12. This tree, okay, this tree is 11.5 feet across. Not circumference, but across. Y'all see how big that is? That's huge. That's two of you stacked on top of each other. Okay? So, that's a giant tree. Here's what the directions say. Illustrates the growth of a giant sequoia. To find the average, let's say, use the diagram which illustrates the growth of a giant sequoia to find the average rate of change. Rate of change. What am I talking about?
Speed.
Rate of change.
Time.
Rate of change. Slope. Thank you. Slope. So slope, do y'all agree that slope is delta y over delta x? Yes? Are you with me? Listen. They're going to tell you who x and y is, so listen to what I read. To find the average rate. To find the average rate of change, and then listen what it says. To find the average rate of change in diameter of the sequoia over time. What's y? Listen to what I read. The diameter of the sequoia over time.
The diameter is.
Yeah, this is the diameter over the time. You see how they told you what is x and what is y? So when we found slope, we used points. Did you agree? We don't have any points. Can I make a point? Can I make the point? What's first? Who's X?
1960.
That's exactly right. X is my time. They told me that's what it was. Y'all, generally X is time anyway. Okay? And then Y is my diameter, 137. Okay? Over here, 2005, 141. Okay? I'm going to stack my points. So 2005 over 141. I'm going to circle my Y's. M is equal to delta Y over delta X. So, who do you want to start with?
140.
Okay, so 141 minus 137 over, what do you have to say on the bottom? 2005 minus 1965. What is 141 minus 137? 4 over, what's 2005 minus 1965? 40. What is 4 over 40 reduced down to? 1/10. Okay, so let me ask you a question. Let's say that you're a forester, all right? And you go to a meeting, a national park meeting about the redwood forest. And the president says, hey, could you report on the growth of our redwoods? And you say, well, the slope is 1/10. What are they going to say?
What a day.
Yeah, what do you mean the slope? We're not talking about slope. I'm talking about the rate of growth of our redwoods. So what does this mean with respect to this problem?
It's growing a tenth of its full size
A whole size?
No. Going in inch.
Grows 1
Every
inch
10 years.
every 10 years.
Big brain.
Very good. Okay, now was Garrison wrong when he said it grows 1/10 of an inch every year?
No, he said a tenth of the size.
Oh, no, it grows, but you could say it grows 1/10 of an inch every year, okay? But it makes more sense to say this is my inches and this is my years, okay? So 1 inch every 10 years. All right, very cool. Anybody got a question?
No.
Okay, so we're gonna do 1.3 on Monday, and then we will test on Wednesday. Good job.